Sustainable Goal 11 addresses cities and communities and is also referred to as the urban goal. The urban areas of the world come in different sizes and densities, different societal affluence or deprivation, different levels of infrastructure development. Their size, their spatial extent, observable also from space, should be measured based on global standards, but in fact all are measured based on national criteria that do not allow for easy comparison across countries and continents. Criteria for defining the spatial extent of the city is a challenge debated over decades. Questions such as what is a city and where does a city stop are not yet answered. The current urbanization figures available from global reports lack in accuracy and provide an incomplete view of urbanization figures in different parts of the world that may mislead decision makers addressing urbanization issues. In fact, national definitions of cities vary greatly. Some countries use population size, some population density, and others a combination of both. The awareness of the shortcomings in urbanization reporting has led the European Commission, OECD, World Bank, FAO, International Labour Organization, and UN Habitat to propose alternative methods of reporting, referred to as Global Definition of Cities and Settlements. The proposal is a voluntary commitment expressed at the UN Habitat III conference. That commitment may lead to the adoption of the global definition of cities and settlements at the UN Statistical Commission in March 2020. This proposal for the new definition of cities and settlements envisages urban centres, which are dense urban areas, towns and suburbs, which are medium dense urban areas, and rural areas. In addition, a functional urban area defines the urban centres and their commuting zones, the rural areas from which people commute to work. The development of the global definition was tested using Earth observation data and population census datasets as follows. First, satellite image archives were processed with image intelligence to extract the spatial urban extent of human settlements and the built environment. Second, the urban extent was combined with population census data to generate population density. Finally, the population density was used to generate a settlement classification. The processed data, population, and settlement classification are used to generate indicators for SDGs and other international frameworks. In fact, SDG reporting foresees a number of indicators. For example, SDG 11.3.1 requires information on spatial extent of the city, population density, built-up density, built-up and population over time. The data are produced from the Global Human Settlement Layer project. This image shows a landscape of cities and rural areas with information available over time. On the left is the built-up and its changes, and on the right is the population and its changes. This information is available for the entire world. Thus, SDG 11.3.1 can be generated for over 10,000 cities worldwide. This map shows the land use efficiency indicator for all of the 10,000 cities, with red dots where built-up areas increase at rates more than double that of the population, and with yellow and blue where built-up areas increase but the population declines. High land use efficiency is achieved in cities marked in green. In these cities, the built-up area per capita has declined. There is another indicator in the SDG 11 family that is recorded using satellite imagery, and that is air quality. Poor air quality is an ongoing threat to public health and is accentuated in the urban environment. Particulate matter has various effects on health, while research also indicates implications for mental health and overall well-being. In this light, the UN has designated as part of Goal 11 the Air Quality Indicator 11.6.2, shown here at national level. The Horizon 2020 Smart Urban Solution project uses state-of-the-art Earth observation data provided by the Copernicus services and the Global Human Settlement Layer to create a tool for delivering information on air quality on a per-city basis. The tool illustrates the sensitivity of the indicator to different city definitions and offers an elegant portal for national stakeholders to better perceive policy implications. The tool helps to compare air quality among cities and identify cities acting as hotspots that drive the national value. The tool goes beyond monitoring and actually addresses SDG Target 11 by allowing informed decision making. These approaches use a common city definition to address urban challenges and open freely available data to provide the EU contribution to GEO, beginning with Europe but expanding to the global scale to help address UN SDG 11.